Welcome, I'm Bill Wake. We're here working on a word game called Betwist. And one of the things we've done is we take our grid of letters and we try and identify all the possible words from that grid. And we're finding that's a little slow. So the first time it took 2.5, 3 hours. The second time we put in a binary search and it went down to about a second and a half or so, a second to a second and a half. That feels too long for a startup. It might be something we can work with in a different way, but at least for now, if I can find a way to make it fast enough to start up, and I think maybe 10x is about right. If it was a tenth of a second, or if it were a tenth of a second, I don't think we'd worry about it. But a second or second and a half sitting there with a blank screen, that's not good. Okay, and so here's the grid board, and somewhere, oh, I took it, did I take it off? It's so slow. It's a bad habit. Okay, let's put it back in content view. Down near the bottom. That was dragging. Oh, we have it now. Okay, let's run it. Okay, now this is Xcode starting up, installing the app. I don't count that. If we just started with the blank simulator and clicked on it and opened, that's what takes a second and a half. So kind of from here to there, But we got this list, and it would be nice to have it in advance, because then our word searches would be very fast, because the words they can generate are going to be a subset of these. And if you generate this list first, we can just look in there instead of looking in the whole giant 250,000 word answers. Can you cache all answers in the game? Yes. Yeah, we definitely would. I just put it in the content view just so we can get it displaying. Otherwise, it never triggers and never runs, and we can't assess it. I guess this is not a filtered dictionary. Okay, so the path, let's see. Well, I lost a slide. I found a link. Okay, so radix tree is basically the generalization of the approach Mudshark suggested yesterday. And the idea is that we kind of try and split off based on letters, or maybe more generally based on prefixes. So let's go take a look at this. I'm not saying we'll do this, but it's just, I think it's worth understanding because it's probably the best contender I have. So you've got a list of words, and basically for a given prefix, when it, you start going down the list, if things diverge, well, then we're going to break up their suffix, I guess. So all these words start with R, so R leads off. All of them then go ROM or RUB. So you can either go down the OM path or the UB path, and so on down to the full words. Okay, the example doesn't show like rube, RUBE, should be acceptable, and so it should be twigged as a possible leaf. Okay, but with this, to answer the question, is a word in the dictionary? Well, you just look at this, and then I suppose you could do a binary search or a linear search on this. There aren't going to be that many, probably. Okay. At the top level, maybe, but we can see. But you do a linear search on these, and you see which one matches your word, the prefix to your word. So if Rom is a prefix of your word, let's say you're looking for Romanos. Okay, so you match R, yes, you match OM, not UB, and you keep working your way down until you get to the ending point. Now, to determine if something's a prefix, you can do kind of the same thing. You're just saying, like, when you get here, are you still a prefix of my thing? Or is my thing still a prefix of you? So I guess really. So if we came in with Romanov, Okay. It would look good, and Romanov, but Romanov is not a prefix of any of these words, so it would reject it. But if we're looking for Roman, okay, Roman is a prefix of other words, or maybe Roma, and then we'd have to break into this one to find out. But it's kind of a generalization of saying, like what we did with a Mudstruck suggestion yesterday was take the whole dictionary and divide it up into 26 dictionaries in effect. So you kind of key off the first letter and get into a smaller dictionary. Now, what I haven't done, just from an analysis point of view, it would be interesting to know how many words, like S tends to be the biggest word. I don't have a paper dictionary around, but the S section is a noticeable chunk of the dictionary. And so the approach doesn't cut it down by an exact 26 because different sections, S has a lot of words, X doesn't have very many, and that kind of thing. This generalization kind of says, well, don't just do it for the first letter, do it for all the letters as you go down. And it's clearly more space inefficient than what we're doing, because instead of one string for each word, we have at least one string for each word, because there's, the end point of it has a string in front of it. And then there are more interior nodes that go as well. So it's got more nodes, it's got more structure to work through. You have to search through lists of things. Again, it may be a binary search, it may be some faster search, but you're searching, and you're kind of walking through. So it's a higher overhead thing. Now, I think this article has some algorithms. Yeah. So there's sort of a lookup, toasting, test slowly. Maybe this is their slow. Okay. So you work your way through the pieces and find it. Okay. And I mean, that's a moderate, especially it's only one piece, it's moderate. Insertion, we have to create the tree at some point, and that means we got to split nodes and split substrings and all that kind of stuff. Now, we're not going to do any deleting, so it's okay, but it's going to be some work. Invented in 1968, and it was called Patricia at one point, although he did it more with radix 2, and we're kind of splatting out by 26 or more. I don't know how you'd say it. We're willing to go out to any number of children. Okay. Not just 2. Okay. He was doing kind of bitwise comparison and two-way branches only. We're talking about doing broader thing. Okay. So what does it do? Lookup, insertion, and deletion order K time. So that's based on the key length. Okay. And instead of something O log n. So now that's not always, well, it may or may not be better. It depends how big K is and how big N is. For us, we already talked, log n is basically 18 bits for us to specify each word. So order K, length of the words, I'm guessing 10 is an average length. I don't really have data, but, whatever it is, it's hard to know the cost. You can't just say, 10's smaller than 18, because you're going to do 10 more expensive things instead of 18 relatively simple things. In the end, you got to do a string comparison. So you're not going to escape that one. All right. But it may well be faster, and it catches something. I mean, it's especially for us, like wanting to know the prefixes. There are search things that you can do that can't answer that prefix question. And for now, we have the binary search on the prefixes. We find the position where the prefix would be a word if it were in there. And then we can check if the next thing is a word with that prefix. And if it is, then the prefix is valid. Not bad, but we're looking for a factor of 10. I don't know if we can get it out of this. I don't know any other well, I'm trying to think of algorithms that would search through a string and also be able to answer prefix questions. I mean, like there's a whole pile of string searching algorithms. What I remember is Knuth Morris Pratt is one of them, but there's an A search, A something. The work algorithmic people did to process genetic stuff taught them to look for a lot of fast searches in strings, because they had strings of ACTG. Okay. agrep is built on one of them by, I'm forgetting the guy's name. I have one of their books. But one of the authors of this search went on to be a VP search expert fellow kind of person or whatever. Okay. Can you use 3-letter prefix in the dictionary? Well, I don't know. The question would be, it kind of comes down to what's the distribution going to be? Now, okay, we did, let's see, one of our searches, well, we talked about it yesterday. Okay, so this one's the 4-letter one. Let's look at this and we can modify it. Well, actually, the 4-letter prefix might be better because we're saying the word has to be at least 4 letters long, and that seems pretty good. Okay, so I don't know. Did we answer the question? How many? Well, yeah, we answered 3-letter and 4-letter words. How many prefixes are there? And it was like 350 3-letter prefixes. So I guess the question would be, well, actually we kind of answered that. If the question is like, what's the biggest box? I mean, I think the concern is if you do this spread and then you get to a node and you find out there's 2,293 values in that dictionary. Okay. It's not that we couldn't search it. Well, we could search it with our binary search, and well, what's that? 10 is 1,024, so 11 is 2,048. It's about 11 or 12 searches. Yeah, 4 letters, they have to be pretty fast. Yeah. Now 3 letters, the cells are going to be even bigger. So, if this is problematic, then 3 letters is going to be even worse, right? Because, OVE starts a bunch of words that don't start with over. So, it's guaranteed to be more than 3,000. So, oven and stuff like that. So I don't know if that's enough. The other one that occurred to me, well, okay, yeah. One thing we could do, and I don't know if we'll have to run some profiling, I think. Okay, so I would, I'm inclined to reverse this and go back to just the binary because that still is the fastest we know for sure. And I think if we optimize from there, we can assess that a little better. But I think that gives us the baseline we're trying to beat. The other way I thought of was when you come in here, we have words and it does a binary search to find, does it contain? So we have 2 key questions. Does the dictionary contain this word, or is this string a prefix of a valid word? Because when we're generating all the possible board, the words off the board, let's get one here. It's going to go PER. Is that a possible start? Yeah, it certainly is. Person, percolator, whatever. PERS. And we're still going to ask, is PERS a possible word? PERSF, I think it's unlikely to be. And we'd like to stop searching. There's no reason to try PERSFW or R, like why would you keep going if you know it's not a word that's in the list? So yeah, so I think what we will do then. Oh, the other one I wanted to try real quickly was, what if we took all our words? I think the cost of answering contains is this binary search. If we were to use a simple set, it would be a hash search, and hash searches can be pretty good. I mean, in a way, they're order one when they work. I mean, if you don't have a lot of things hashing to the same value, then the hash distributes your words across a bunch of possible ranges. And so I don't know what the internals are for Swift's dictionary, but some dictionaries will, if you start getting conflicts, two things that match the same hash, they'll put it in a bigger dictionary and try a rehash and see what happens. Other ones will, other ones might make a list, like a linear list of everything in that bucket for that hash. Other ones will try this rehashing approach. They'll take the word that you hashed and you found a word's already in that slot, and they'll do another hash function and try another slot. And when you look it up, you have to try the two slots, or the n slots, because if you have n words in there, it might make contains faster. Okay, it's not going to help with prefix because a hash has, the point of it is it sort of randomizes every word. Even similar words are different, go to different hash entries. And so knowing the prefix of a word doesn't get you to any real chance of finding a hashed word. So it only would help this function. All right. So I'm going to reverse. Let's see what commit tells us, what changed. I think I can just undo vocabulary. We'll keep the test. Yeah. Okay. So let's revert this one. Now, whatever the word is for an expert in using instruments for profiling, I'm the opposite. I've tried my way through it. It hasn't been easy. I mean, I've used profilers, quite a bit before in other languages, but just this Xcode one is not helped me. I did a little quick read and I didn't see anything that lets me get the call counts. I had thought originally we would start today. Oh, wait a minute. Okay, I'm just going to comment these, uncomment, or delete these comments. They don't. I originally thought we'd start today by putting a counters in for contains and has prefix. I think instead we'll just rely on the profiler, because that's really, me speculating that contains and prefix are the bottlenecks. I'm also worried about our generate, but I don't know which one's the bottleneck. It's very hard to predict. Even, let's say, like, go unwind languages and compilers like 20 or 30 years, and you had C, usually the compiler mapped to a pretty straightforward, version of, you could make sense between what the compiler did and what it generated. Yeah, I think a map with hash word might do it. In effect, a set. I think set is really, it's designed to answer that question, contains, but we are going to run instruments first. Okay, so it's going to build. And instruments should have a way for us to say, run this app, and then let us look and see how much time did it spend in different methods. And it can look in methods or their children, depending how you configure things. Okay, so let's get this over where you can see it. All right, so we're going to try Swift CPU profiler. That sounds like what we want. I don't see anything that looks like it counts. Oh, CPU counters might do it, but let's try it. I've never, well, I can't say never, but I've tried these things. I don't know what I get. Recording mode immediate. Process and display all recorded immediately during processing. Yeah, I guess we can live with deferred. Okay. Instruments. Is that where we are? Sample by time. CPU name unsupported. This is not promising. All right, does this record? Okay, he's running it again. Well, that was fast. That is different. Okay, and can I stop? I don't know if I get enough information in, a few seconds, but we'll see. We could submit words and stuff. Okay, CPU counters. All betwist. Okay, 556. I don't even know what that code is there. Instrument. Okay. Well, it splits across a couple CPUs. There's betwist. Oh, that's process number. Okay. Let's make this a little bigger. Okay, so 100%. There's start thread, closure to, and view render host. Well, I don't know what's going on in here, right? 86.5% in start sim. Yeah, I'm not sure that's helping. Okay. Heaviest stack trace, closure to, and view render host. View graph update output. Okay. Well, it's almost like it feels more like it's checking from the Swift UI end than I'm not seeing our functions here, put it that way. Maybe I'm just not going down deep enough. Dynamic load, that just doesn't sound like it. Start through 3P thread. I mean, and it doesn't seem to be stuff in our thing. Okay, so let me, how do I go back? All right, let me delete this. Okay, let's go to a different instrument. CPU profiler. Okay, can I delete this? How do I can. Okay. CPU profiler to record kernel call stacks. I don't care about the kernel. Okay. Let's run again. Okay, and I'm going to try stuff. E A T H. Yeah, that's what I'm thinking, is make words a set and do prefixes the other way. Okay, let's stop. Okay, so we did 4 of those update things. All right, so here we're trying to understand how much time went into each piece of things. It all adds up to 100%. Start dynamic load. Start, I mean, like if that's 93%, 86%. Okay, main betwist. There we go. Now we're going to have to work quite a ways down. 78% seems like a lot. Kit render component. Application main. See, there must be a way to filter. Okay, well, this one might be interesting. Heaviest stack trace. Well, okay, we do see like our overall look at that was my opening burst. That's probably each letter, Leath or whatever I typed. Almost on our way to leather. All right. But then now here, it's funny. Everything's coming in on closures. Okay. Whoa. Try all extensions. Okay. Yes, that's one. So yeah. So this, let's see this. Okay. So this is our try all extensions, which calls, contains, and a bunch of other stuff. Okay. Now they're saying this is 750 milliseconds. I don't know what MC is. I assume it's milliseconds. And of that, game.try all extensions has, you know, 2/3 of it. Okay. And then we can look under that. Specialized for each. Outlined release. I don't know what that is. Trial extensions. Well, I think it's recursive, so I think we're kind of getting trapped in a little bit of a loop there. Okay. Here's hasPrefix and contains. All right. So what I do get is hasPrefix is spending 79 MCs, if those are milliseconds, and contains is spending 48. So hasPrefix is slower. And if we drove contains to 0, like what we found the perfect something even better than set, we would cut out 48 milliseconds out of 750, say. You know, it's nice, but it's not going to change the, you know, what is that, 1/15? So 6% faster. I mean, I like 6% faster. But on the other hand, it also says it only spends 2.8 or 1.8% of the total CPU. As well, where I lost it. Yeah, 1.8. Okay, and then in this, there's not much to go by. There's some string compares, subscript gets, static strings, and that's all kind of the leaf level stuff we're doing. And I don't see us escaping it. Okay. So what that, well, I mean, hasPrefix is not taking that much either. I mean, between them 150 out of 750, you know, that you'll 15%, you'll kind of feel it. There's a bunch of time being spent elsewhere that I can't quite judge. Well, now a lot of this is recursive. Okay, that's ZStack. That's all view stuff. But here's trial extensions. Now that seems to me, I don't know what GCs are. Maybe I'm misinterpreting. Maybe that's not. Oh, megacycles? Okay. Okay, well, if this is 1.16 billion cycles, I bet you're right. That makes sense. Seconds wasn't working out for me. Okay, so we're doing a lot of work on game all extensions. Interesting. Okay, I don't see anything else. Everything above here is that. Okay, so 2.63 total. Now I know there's some of this is, I mean, we're displaying all these views and all that stuff. That takes a bunch of work. You know, it's not nothing. But this 1.16, I think that's the highest one of those I see. You know, of the 2.63 total, 1.16 is try all extensions and what it calls, which includes contains and our stuff. Now, for each, open neighbors is down low. I don't. It's really hard to pull a recursive function apart and know what's going on. Now, I don't know if there's a way to. Okay, book 1 million cycles out of 1 gigabyte, 1 gigacycle. It's not that much. I mean, that kind of suggests. Well, okay. I think what it suggests is if we could figure out a way to do try all extensions faster, that would make more difference than getting contains or hasPrefix faster. Now, the profilers I've used will let you. Is this what I want? Usually they have a way that you can go like by routine and find out how much it spends. I don't know that this is that. I think this is a different view on a recursive kind of structure. It looks like things are calling things. Here's game trial extensions. Yeah, okay. Yeah, oh, what's this guy? This purple thing. Init. I really wish I knew what that was, because that seems to be the deep recursion of some sort. It's Switch UI core, and this is layout. I don't think that's. No, the view I want is very flat. Oh, maybe it's samples. That could be it. Well, I don't think back twist is it. Lots of string compares for sure, but I'm not. Anyway, most of the ones I've used, you can get the view we started with, where it's kind of the recursive view. Each component, how much does it and its children contain, and then you can open up and see the children, how much they contain. And then there's another view that sort of slices across that and says, here's a routine, regardless of who called it or who it calls, how much time do you spend in this routine, and how much do you spend in it or its children. And that's kind of the view I'd like to see, is like which function is which is spending all the time. But I have kind of a conflict, and I don't know if we can. I mean, can we make it threaded? Well, so the idea there would be, we would say, like, let me take an example. We got this far, and then we'd kick off one thread with VAPC, VAC, VAPH, VAPN, VAPI, VAPG. I mean, I don't think there's any more parallelism than that, except you sort of, like when you start, I guess you could start with your word on each individual letter, and you have 25 threads going potentially. I mean, maybe there's something there. The challenge is, like, threads have, I mean, it takes a number of instructions to open a thread and manage the thread and all that stuff. So it may, I don't know if it will pay off or not. I mean, I'm definitely not rejecting it, but I guess I wonder, is there anything we can do to make this search from, as it goes through, like here, it's got 1, 2, 3, 4, 5, 6, 7 neighbors open. Is there some way to not search beyond it? I don't know. I mean, VK is already pretty bad. There are no VKCAs, in our list of four-letter prefixes. Uh, yeah, so I don't know. Okay, I think uh, I think trying out the set is very cheap, and so we should do that. I'm not convinced, based on this, where it seems like try all combinations is the tough one, which I expect to be the case because it's sort of like it's sort of like it's not really 25 exclamation point 25 factorial arrangements of letters. um it's less than that. But something factorial is a hugely big space to search. Now this is constrained as it goes, and as you get crowded in, here I only have three choices now, and here I only have two choices. Well, I can wrap around, but I guess here, well, H has four choices, N has three choices. The number of choices is going down as the board gets crowded. But I don't know how to reduce that. I mean, I guess the only reduction I have is if you can tell, the earlier you can tell you're going in a bad direction, like, the better off you are. Now, the four-letter prefix thing, even the three-letter prefix thing, maybe that's worth a look, because we don't have any words. We did finally filter our dictionary, so it's only got four letter or larger words, and yet, like, we could look and say, is this a valid prefix? VKC. Why are we going to do VKC, SHP? None of them are valid. So that's I think that's the other promising one, is to say prefixes. Let's check them against a fixed list, a fixed and small list. I just don't know. I mean, I think as we're doing this, VK is not, even this, right? VK is not a valid prefix. And we answer that question, I believe, right? Because we do the search for that prefix, VK, and we don't find any, and we say, okay, there's no. But the prefix search, right, it's searching 250,000 words. It's not searching 300 prefixes. Yeah, that's true. So, I mean, that would definitely speed up hasPrefix, because we're searching a handful of possibilities instead of a huge list of possibilities. Now, login goes down pretty quick. Even if it's 350, right? 256 is 8 bits, 512 is 9 bits, so nine searches instead of 18. So we'd cut out half our searches, maybe more. All right, let's try the set. Okay, yeah, let's get a plan. Okay, try a word set. So this would make contains run faster, we hope. Although we pay a cost to build that set, and then we pay a cost to search it. But we'll try it. And then the second one is try a 3 or 4 letter prefix dictionary. Now, I mean, maybe the 3 suffices, because like most bad 4-letter prefixes are also bad 3-letter prefixes. Yeah, the build's a one-time thing, but like if it takes 5 seconds to build it, it's not going to speed up my startup time if I compute these words at startup time. Now, I should say my backup plan D or so is, don't do this at this time. Basically, we could run this as a separate thread, and by the time they asked us what are the solutions, we'd have had plenty of time to do it. I mean, as long as whatever took more than a second, and I think in our case, boom, boom, we're already up to a second, and I haven't typed 3 letters yet. So, in effect, we could defer this work. It wouldn't help us with looking up words, but we never had a problem with that anyway. Even when it was a linear search, it was fast enough for one word lookup. So I do have that in the pocket that says, calculate this when they ask for it, or while they're playing or something, either in the background or not until they ask for it, and then let them be chagrined because all these words that they don't never even heard of, just projecting. Okay. Let's see. So yeah, so I think that's our 2, I mean, in our plan Z, of don't generate the full list until later. Okay, that's also a possibility thing. It's well, at one point I went back to school to get a PhD, which I didn't finish, but I was in this space of information retrieval and searching and that kind of stuff. So I'll warn you, it kind of wants to suck me in to a deep dive and figure out, what's the fastest way to get these things. And we didn't try the Bloom filter, which was that multiple hash table thing. It's very clever. I mean, I love it, but that's the one we have multiple hash functions. You hash each word multiple ways. It throws a bunch of bits in the dictionary. And then if you have 10 hash functions, every hash function would have to put you in the same place to get a valid word like that. And so you can kind of control it's a space trade-off, but if you put a word in, odds are if it's got the right 10-bit set, it's probably in the dictionary. Okay, generate the list while animating. Yeah, we definitely can do that. I mean, we have sort of an opening screen, and you could, I mean, I could see something that, reverse explodes the board, implodes the board into place, or something that takes a second, and you're only paying it the very first time, when you open the app. If you completely shut it, if you just close it and come back to it, it doesn't throw everything away. It's only if you like double click, get rid of it and restart, or restart your phone or something like that. And it's like once in a blue moon, you pay for these 1-second startups. Like that's pretty minimal. And like you say, if it's animating and people, it keeps them occupied as viewers, and, it's fine. Okay. Let's see. Bloom filter, multiple hashes, for a probabilistic answer. But that one also does not really do prefixes. Okay. Word set. Let's take that on. All right. We have a vocabulary. This was we changed it to 10,000. Okay. That's a little better. And what's this one? Did we leave it 1,000? Oh, we made it 1,000,000. Okay. So, this is contains. That's definitely enough time to see it. We saw it in like a second and a half or something. Yeah, display the letters one at a time. We can definitely find something. I was also thinking of some sort of like start with the board and sort of warped board and then unwarp it kind of thing or something. It's not hard to spend a second doing an animation. All right, performance test. Okay, so now we create words, and then let's create word set is set of string. String's already hashable and all that stuff. So word set equals set of words. Okay, so it'll build that. And then our contains, we're not going to search words. We're going to search word set. Whoops. Word set dot contains word. And I mean, that's exactly what set is designed to do. If we didn't need prefixes, it would be a good way to do it, probably. All right, let's run this test. Well, no, let's put this back. Run this test. See what we get. Okay, this is contains. Good. And I'll run it, like 3 times. Get a little bit of a bead on it. Okay, so 1.243. Theoretically, it's a different random element. 258. Yeah, I mean we're in the ballpark. 1.293. Okay, so 1.25-ish, something like that. Okay, and we'll make our change. We built the list, but we don't count the startup time, so it's not misleading. It does affect our runtime thing. Okay, that should be all it takes. And we're paying a space penalty for this, right? Because we take our words, 0.905. But our space penalty, 250,000 words, 10 each, 16 letters, 16 bytes each. It's not bad, but that's nice. I mean, that's a noticeable speed up. Do it again. .906. And one more. Okay, I guess it's about 0.906. All right, well that's a pretty good winner, I think. Let's run the app and see if it feels faster. I mean, I don't know if it will or not. We are paying a more startup cost, but we're hopefully getting it back by searching so much faster. All right, so run this. That's slower. We'll do a fresh run. Okay, so we're not paying Xcode. Yeah. I think that's faster. Oops. Can't click that fast enough to get that consistently. I think it's faster. It's a 250,000, give or take, 250,000 ish. However, the thing we don't know still, and maybe this is worth the effort in here. Okay. Let's say contains count 0 and prefix count is 0. And let's see, I'm doing this manually, which I don't. We'll get it. Contains prefix count. Okay. And these are var. Okay. So I guess, oh, right. It shouldn't, the implementation of this should not affect how many times it's called, because that's driven by the board generator. Okay. Well, I don't think it's a bad result, because the question is how many times does this thing ask for a word? We know it's asking a lot. We know it's asking contains a lot, because it's asking it, do you contain OH, OHB, OHBW, OHV? What about prefixes? So I don't know how many times it is. I suspect prefixes is more than contains, because everything generates a bunch of prefixes. There are 6 or 7 candidates here. And so it has to call prefix multiple times to ask if it should extend this word, and eventually it gets to the next one and it says, okay, ask this word. So let me quit instruments just to be, nope. So if this could generate a billion partial boards. I don't know what the answer is, but I'm very much guessing hasPrefix is going to be bigger than, multiple times bigger than contains count, and they're both going to be pretty big. But that's a guess. I don't know. All right. So I think a run, and then I'll. Is the list just a million? It's a million words to look up. Yeah. Okay. And what that doesn't tell us, it doesn't really tell us if a million words you look up and they're not there, right? Could be more expensive. I don't think it is, because the binary search just locates where it should be and then looks at it and decides if it matches. So I don't think the cost is too different, but it is, we are only looking at one end. Okay, so I guess I will run this and then set a breakpoint after it comes up. And if I do anything, it'll trigger it again, and I can see what the count is before it gets going on it. Okay, so at this point, these counters should have stuff in them. So I'm going to break here and here, and just clicking one letter should trigger at least one of them. Okay, so there's the first one. All right, now let's see what contained count is. Okay, well, that's smaller than I thought. Okay, so that's how many times do we call contains, generating our whole board of possible words. All right, and we'll continue. And let's look at prefix count. Wow, they're the same. And they're low. I was sure that was going to be millions. Should they be the same? Okay, so we come in with a word. Sorry, a recursive routine. I have to talk myself through it. We come in with a word. We generate. We take all the open neighbors and build a new selection, and we ask, do you contain this word? Now, have we appended? I guess we've appended we appended each letter from the word. Okay, so for each neighbor, we do append its letter to the selection, and then we ask, hey, did I get a word? Okay, and if so, we insert it, and if okay, and then we go on and say, okay, is this word a prefix to another word? And if so, we try it. We call it recursively. So at each neighbor point, we're definitely calling contains once and has prefix once. Okay. It's not if it fails. Um, it's just whether we got a word. So if I'm looking for the word leather and I've got leath, it's not a word maybe. um, but so contains failed, but it's still the prefix of something, so it keeps going. So they're equal at this point. And then if we come in again, then we call recursively. I guess we're calling with the open neighbors of that, which is presumably, well, it could be smaller, it could be the same. I guess it could be bigger, but it's never more than 8. And you take any valid one and you ask, now do I get a word? That seems okay. So yeah, it's going to call these two exactly the same. That definitely didn't hit my intuition. Um, so yeah, they're both always called. But I somehow thought, I guess I was thinking that if it doesn't have the prefix, if you just got this word, it either was a word or it wasn't. But if you try to go on from there and it's not going to be a word for any letter, um, then why? Okay, then it doesn't go. Then it doesn't go any further. Exit if it's not a prefix. Well, prefix. We still don't know if it's a word because, um, well, um, I don't know what's. I come with 2 words. I guess I just need one with an S, right? Okay, so based and bastes, with the S on the end. The based is a word, so we got to accept that one, but we want to find out if it's a prefix. Well, it's a strict prefix. Is there another word that starts with based? Well, yes, there's bastes. Now, maybe maybe there's a better question to ask. Because I think it feels like the work is duplicated, Because next we come in with bastes and we're going to ask, do you have any prefixes? Well, BASDE, all that stuff was a prefix. And so we're searching across that. Um, so, uh, yeah, because if we're extending this word, we know we don't need to search the whole dictionary for prefixes, right? So we've definitely, can we check a guess without the last letter when we look for a prefix? Well, we already have, right? Because whoever called this called prefix, um, I don't know, let's assume BAST is a word. I have no idea. But it's certainly a valid. We got BAST. That's not in the dictionary, but it is a prefix of valid words like based. Um, I don't know, basting and bastes and other stuff. Okay, and so we already looked up that word, but I think the thing we leave out, like when I when I find this word, I know that all its extensions, as far as extending the selection, they're gonna they're gonna be some word that starts with that same set of letters, and it feels like we don't keep that information. Now maybe we can't keep it. But I could see something that like I, we check if the word is exact and has prefix. Okay, let's see that. Um, I I don't think we do. We look for it, the prefix. Um, 46. Oh, if word suffix equals prefix. Okay. If so, that says the prefix you're looking for is an actual word. Then we look at the next word, if there is one, and if the next word, I don't want to say this. There's definitely some way to flip this. Oh no, it's index plus one versus index. Okay, so if we find BAST, let's say BAST is a word. Okay, we're gonna look at the next word, which is BASTA, BASTA, and um, if there is a next word, which there will, unless you're at ZZG or something, um, then we make sure that next word starts with BAST. Because if we were at, well, let's, what's one that wouldn't have anything? Let's say Pete, PEAT, has no words that start with Pete, right? So if there's Pete, but there's nothing else, there's no PEATR or something, um, then we're looking at Pete and PEAU, and we say, oh, it doesn't start with PEAT, it starts with PEAU. So there are no other words with that prefix. But yeah, somehow it feels like we should be able to use, like, there's more information here we're not using. And what I was thinking was, like, what if you knew the range for all the words that start with, let's go back to BAST. We know there's BASTA, BASTE, BASTI, you know, but BASU, like everything from BAST up to but not including BASU, is a word of, is shares the prefix. Now maybe I'm reinventing tries or radix, whatever we called it before, radix structure, radix search. But it feels to me like when you're in this game here, like we found that it was a prefix. So we searched in the dictionary till that point where it was there. And I feel like now we should take all the words with that prefix and, like, why don't you just tell me the letters that could be next? And, if the only possible next letters are A, E, and I, like I don't need to do all possible selections beyond it or something. It's like there's more information we could squeeze out of this. Now, it would kind of cost us. It'd almost be like searching for BAST and BASU and finding the range of them. Add the word if the prefix is the word index, continue with index plus one. Well, we don't. Is that going to work? Add the word the prefix is the word index. We certainly do that. Then continue with index plus one. Only in the search for it, you mean? In the search, we'd start at index plus one. Yeah. Um, hmm. Well, okay. Add the word if the prefix is the word at index, but we still need to add that word, right? I mean, we need to know if it's in there. It's not enough to know we have BAST. If, well, do pasta then. PAST. Past is a word. Pasta is a word. So when we see past in there, like we want to take that credit for that word. Um, but there's something, yeah, there's something to this that, like, I think what you're saying is, like, if we do this contains, we found where that word starts. And then the has prefix, there's no reason it has to look at the rest of the dictionary. It could start right there and answer based on that. Even if it just took from there to the end of the dictionary, that'd be kind of the cheapest, easiest one. We'd potentially cut our dictionary in half or something. Um, that'd be worth something. It, the thing is, though, it's like we're still. Hmm. Well, that puts a bound on things anyway. We know for at least for this board, it took us 155,000 tries. Um, we do result, insert, and skip the check. Go back to vocabulary. Well, okay, so I mean, this is the vocabulary asking the question, right? I mean, it seems like vocabulary should be um, in charge of things. Now, the thing that might happen, well, if we were doing it with the binary search, we could cache and say, hey, if you found word, you found it at position whatever, and then check prefix. Am I searching for a string? Oh, well, I don't need a binary search to start at one. I can start the binary search at the string. Um, I I don't know, that feels. I mean, I definitely get that this is disappointing in a way that we're rechecking that. Now, maybe there's a way to flip it around. I mean, well, okay. So flipping around would be telling vocabulary, hey, here's the result set, and I want you to look this thing up in contains, and then what? I mean, if you find it, like this would be kind of combining contains and has prefix. I just don't know. I mean, I think it can relatively cheaply find the prefixes starting where the word should have been. I did think there were a lot more than 300,000 lookups to make it slow. Comment out 141 to 143, and it has prefix. Insert the word when you find it. Yeah, but like, I mean, having a prefix is really not. I mean, that's, I don't know. It really couples these things. It's like the answer of do you have this prefix feels like it should not be related to how do you do a selection and how are you going to insert it and where you're going to keep the answer and stuff like that, because the prefix, knowing it has a prefix doesn't give us the words, right? There could be thousands of words that start with those four letters, and we don't want to, we don't know what letters you're going to be searching for next based on the board. So I don't think that's going to help. hasPrefix, insert the word when you find it. Well, I think what maybe a way to interpret it is we're going to ask, well, what if we got two results back? One is this word contained in the dictionary, and is it a prefix of something, these other words? Now, hasPrefix. Yeah, so is it in the dictionary, and are there other words past it that start with the same letters? And I think what you're saying based on this, if words index equals prefix, we know the answer. It is in the dictionary, and our return value could be yes. And as far as is it contained, we've just answered that. So the benefit of this would be we would not need a separate lookup for contains. The tricky part is it's returning two things. It's returning contains. Well, it's two flags. Do you contain it? And is there more? Okay, let's try that. I'm going to kind of treat it like a spike, and we'll just see if it does any good for our performance. And if it does, then we'll go rework our testing stuff a bit. So, and I think just a new method in vocabulary. Okay, so this is, we'll work on the name. Contains and prefixes. Target is a string. Returns bool. And again, we'll refine it if it dramatically speeds things up. Okay. And let's just keep all this. Okay, and then return false. If the prefix isn't there because it's too far, then it can't be a prefix of other things. Okay, so false. I gotta change. Well, let's call this prefix, and then I'll change it. Whoops. Okay, target words false. If the word is there, then the contains part is true, but it can't be a prefix because it happened to be the last word in the dictionary. Okay. Return word sub index +1. Okay. And this is true because we did find it, and now we got to answer that. Okay, and now this one, we did not find that, so it's false. And that. Okay, and let's build a test for this thing. Performance test contains and prefix. Okay, and we'll do, I think we'll basically take this test. Okay, so instead of calling contains, let's call contains in prefix. Contains and prefix. Contain prefixed. It's 2 booleans back. Okay. What's the problem? Contains and prefix. I think it's just, prefixes. Okay, so let's make sure this test runs. It doesn't prove it works. Okay, good. A prediction. And I don't know what, did we run 10,000? We were in 1,000. Okay. Oh, did I copy the disable? No. Where's my breakpoint? We'll rerun that. Okay. All right, so this is count is 1,000,000, 1.551 seconds. One more time. Our runs have been coming pretty close to each other, so I'm not, like, usually you set things up, you run them 10 times or whatever, you know. Okay, 1.578576. Yeah, close enough. All right, now let's do the well, our last contains was 0.9 with the set, but let's do the 2 call version. Where's contains and prefix? Okay, let's call let contained equals set dot contains random words subindex, and then prefixed set dot hasPrefix has word. Okay, so now we're running the same thing the old way, and we predict it'll save something. 200 milliseconds. So this is new. It's definitely slower. 1.743. Okay. And run 1 or 2 more times. Okay, 744. Okay, so yeah, 200 milliseconds is right spot on. Good intuition. That's 1/5 of a second. I mean, that's a pretty good jump. Now, do we ever call contains? Let's see where we call contains, because I think we don't need it other than this. Find selected symbol. Bunch of tests. Okay. That's reasonable there. Okay, this is collect. Collect adds that word to the dictionary, right? For length. Oh, this is getting all the free words. That's reasonable to me. Yeah, but if well, the question to me is, do we if we adopt contains and prefix, we could clearly make contains call contains and prefix. Um, if it's doing it only when it's like this is happening when you submit a word, like it calls contains to make sure it's a real word, and then it does something one for each length from four to the word to see if any of those prefixes that you already got were words. So it's again, I kind of say 10 letters. That's better than my average guess by far, but it's not a huge cost. So if it calls the contains and prefixes and throws away the prefixes part, I don't think it's going to affect. It doesn't matter for this one. Collect is called once when you get a word, and it was fast enough when we looked up, when we did a linear search. So I guarantee it's fast enough doing this sped up search. Okay. All answers, on the other hand, okay, this is going to use the new approach. Okay, and then contains. Oh wait, what's all answers? Oh, all answers is the top level thing, trying it once per thing. It feels like this could be folded together somehow. Contains and prefixes are just to create a list of existing words. Well, yeah, we could do that then, right? If we had the list of existing words. Yeah, it's definitely fast enough to validate the current word. But we would get. So this is kind of a stage 2 thing, I think. But yeah, so in if we use contains and prefixes in the trial extension stuff, all answers, we're getting those 200 milliseconds. Well, we don't know what it does in real life. We haven't tested that yet. But assuming it saves us something comparable. I mean, that was a test for 1 million, and we just saw we only had 155,000. So it may not be as much as we hoped for. But I think what this says to me is if we the only time that performance matters on contains and prefixes is in the generating all the answers. If you're at the point where you've got a word you've guessed and you want to click submit, and it's got to look up contains and prefixes, it's paying a little extra look for the prefixes time wise, but it's so much less to do this with the binary search than it was in the linear search that we know it's just not going to be a problem, even if you're throwing a little information away at that point. If it were the other way around and the dictionary, the all answers thing was the thing that paid extra, 50% extra for it or something, that would be concerning. But, when a low volume thing pays extra, I'm just not going to worry about it. All right. Now the question would be, let's put it in and see what happens. And maybe this is kind of refactoring. I mean, it's changing an internal structure algorithmic wise, but all the tests and everything should still work and not care. There might be some tests we want to do because of the new algorithm. All right, so I'm going to say let contained and prefixed equal vocabulary dot contains and prefixes on selection dot guess. Okay, and then this. Oh, all right. Yeah, if contained, then we want to do this. And then if prefixed, we want to do this. Okay, and so we got this thing that's doing both. All right, now I'll run the app, and maybe I'll run it and then, well, we'll see what it does now, but I think we'll restart it and without Xcode involved and see how that looks. And we're hoping for some speed up, some sense of speed up. I'm not getting it. I'm really not getting it. Okay, let's. Okay. Gosh, it's a little faster, I think, but not dramatic. I mean, it might be 15% faster feeling to me. I don't know, 10%. Yeah, I mean, it's right on there. Okay, so, well, where's that leave us? I think we'll take a break in a minute, but what I think I feel is it's a noticeable improvement for a slight kind of bending of the natural interface of this thing. It's sort of like there's a like calculating the sine of something and calculating the cosine. They share 3/4 of the work, and so some systems provide a sine cosine function that gives you both answers. And I feel like we're getting that kind of situation here, like knowing if it contains it and knowing if it prefixes it. That's all pretty. That's pretty much, they overlap a lot, and it is worth bending the interface a little. I do have. Let me make one more quick change. I think I'm going to say let's take out the word set. Where's contains? Okay. And we're going to let this thing call contained and ignore me equals contains and prefixes of word. And then we'll return contained. Okay, so I'm explicitly, we're losing that extra set initialization, and we're using the contains and prefixes. Okay, let's run. Now, it didn't seem like creating that set felt like it added a whole lot, but it had some cost. All right. Nope. Nope. I have to double click this thing. Okay. I don't know if that made much difference. I think conceptually it gives us one less data structure run around. That's kind of worth something. If it's no more expensive, it might be a little faster. Okay. Let's take that break, 3 or 4 minutes. We'll come back. We'll clean up. We'll decide if we need any more tests, but we'll take this combined method as being the one we care about. And I think that will that'll get us where we are. I don't know. Maybe it's enough that we can set this aside for now. I don't have something that says I run 10 times faster, and I don't know if it exists easily. 155,000 lookups. Yeah. How slow is word validation with contains and prefixes? Okay, yeah, we can find that out real quick here. That was 0.905906 last time we ran it with the dictionary. The set. It's going to be more than that for sure. Well, I don't know about for sure, but yeah, it's probably going to be more because it was more when it was using binary search. So it's the same as that. .445. That it was 1.24 with just contains before. I don't think it's going to be noticeable when playing. Yeah, 1.4. Okay, so it's certainly slower. But we did 1 million lookups. You need to do how many? We got to find a word that's long that has another word in it. So twines. S, because it has twin, twine, and twines. All right. And so we should get credit for all three. Yeah. Now that felt a little slow, but it's also redoing all this. So that part doesn't count. Yeah. I don't want to say no way, but we're looking up 4 to 7, from 4, we're looking up the words twin, twine, and twines. If we had some other, let's see what else we got in here. I'll cheat. Annexes, wahinis, I don't know. Most of these don't contain a lot of subwords. Not seeing any off the top. Okay, so, and that may be that may be common. Yeah, I mean, war and ran. There's only, it's looking for 4, 5, 6, letter count 4, 5, and 6. It's looking up 3 extra words basically for a 7-letter word. How many 10-letter words do we have in here? I didn't see anything that looked like 10 letters. Maybe some 8s. Handset. Yeah, I mean, for this set, odorant. Warrison, that's all about 8. Yeah, so at most it's looking up 4 or 5. Not a problem. Looking up 4 or 5 words with a binary search versus what it did before, look up one word with 250,000 linear search of 250,000. All right, let's take that break and we'll consolidate and decide what's our next project. See. Okay, welcome back. I did a search for hasPrefix before we left. I didn't really look at the results. It does still have that because I only modified one of these two, which is really annoying. Let's put this down here. So we did it on the one at the top level. We didn't do it on the one that walks through things. And I think we still need to figure out if we can combine those somehow. Okay. Whoops. We need this line too. I mean, if nothing else, we can make a subroutine that does this section of things. Okay, and then comment on these. We'll run. That seems really slow. Oh. Okay. Bad access. So that's a bad sign. A bad access to memory terminated the process. Okay, I guess, can we see selection? Unreadable. Okay, there's our grid. Selection has one value, 0, 0. So he's trying to select the T. Huh. That really is weird. I mean, we know selection.last is not nil at this point. Yeah. So the only things that make, I mean, the bad access, right, should be coming from these bang things. I'm going to run it again, but that's really bizarre. I may rebuild, but that should not have happened. And it's looping. Okay, let me make sure. Oh, wait a minute here. Oh, we got new selection. Well, I don't know how it gets here. I mean, that's really weird. But yeah, something has changed here. Try all extensions. Yeah, this needs to be new selection. To match. Oh, wait a minute. Did I use inconsistent names? No, down here. Selection. That was new selection. Okay. All right, let me run it again that way. Yeah, it could be a Stack Overflow. Yeah, so if it was never extending the selection, it was trying the same thing over and over again. So yeah, not good. Okay, that's a little more promising. That was, oh, no, I didn't close it. Yeah, that's about the same. One, two, yeah. Okay. So I think let's run tests. Theoretically, all our tests should be good. We sort of well, let's make sure there's no weird exits and has prefixes. Oh, we left our performance running. And there was a failure. No? Oh, skipped. Okay. Yeah. Okay, that's fine. Well, I don't want the performance test running for real, but let's see. Has prefixes. Oh, not that one. This one. This is the one I want to worry about. Okay, so try to find the word, and if it's out of range, we didn't find it. That seems correct to me. It was after the last word, and where it should be is right after the end of the list. So that means there is no word found. Okay, and then beyond that, we have the two cases. Okay, and again, if we're at the end of the list, there's no word found after the prefix word. Okay. Okay, I think we're at a stable point. Let's put this disabled again. Performance test. That one and that one. Okay, run tests, make sure they're clean. Okay, 0.05 seconds, much nicer. All right, I'm going to commit this like this, and then we're going to clean things up. Okay, so change how words are searched. Words and prefixes are searched for. I'll say modest performance improvement. I mean, if we got 200 milliseconds back, that's pretty good. I think it's possible we did. It's hard to tell because we're comparing me sitting here counting 1001. But it felt a little more interactive, but it's still too slow in general. So in the long run, we'll have to come to a different place, I think. All right, so now let's take out this junk. And one more. Okay, I'm going to take out contains count too. Let's get rid of all these breakpoints. Okay. Counts. Okay, binary search index, binary search. Do we do binary search? We don't. And I don't think anybody calls this hasPrefix anymore. A bunch of tests. Okay, those we'll need to, oh wait. Yeah, we'll need to work on those. Well, I don't mind doing the same thing I did here. Let's do that. Are we ever returning true when the word is found in contains and prefixes? Are you saying true for the first slot? Yes, we do both ways, true and false. And this condition can be true or false. So this is the situation where you picked a word at the middle of the dictionary, not the end of the dictionary, or anywhere other than the last slot in the dictionary. You pick a preview, a prefix. It's in the dictionary. So that's why the true is on 47. And then if the next word starts with those 4 letters, or however many there are, then that controls whether the prefix is there. So we found the 4-letter word, the next word, we check if that has the prefix or not. Either way, that tells us whether there's more words with that prefix. So that should be okay. All right. And this is prefix. Okay. I like target as a better word. Okay, now I don't think anybody's calling this. I don't, boy. I worry that if I delete it, I think I'm going to reference it. This is for a plain contains search. Using the programming Perl's binary search, but we no longer use it. I imagine I'll delete that at some point, but I don't think it's obvious this is what you should do unless you have that book sitting in front of you to say, oh, I should do, I should do the binary search thing. Now we could call this in contains and not do the contains and prefix thing. That would be reasonable. It'd also be a little faster. But I think I'm working towards setting this aside more than trying to do some fancy approach. I think that's old. Okay, so this. Now, I guess I wonder on these tests for prefix. I guess, in effect, they are tests of contains and prefixes, and we can leave them alone. Wow. 0.019, that's pretty fast for us. Okay, all right, so let's check this in. Remove dead code and comments from vocabulary. Okay. Try a word set. Well, we did. I guess that's reasonable to say. This is the 10th. Okay. Try the prefix dictionary. I mean, I guess at this point, these are ideas for faster lookup. And I'm going to save those for later. I guess the question to me is, would they still be effective? And I think the answer is no. Because, well, the answer I have is no, because we now do prefix and contains. And so you can't answer, does it contain this word based on the 3 or 4 letter prefix? I guess if you knew, well, that's not true. If you knew it wasn't starting out that way, then you could say, like, nothing starts with these 3 letters, so I guarantee your word doesn't. That might be good. That could be a good thing. I mean, the list of 3-letter prefixes is not that big, but it would filter out a fair bit. Okay, another idea, don't generate the full list until later. Okay. So now, do I want to use this list of words during the game? I don't know. I mean, I think we've done this. Whoops. Okay, that feels fair to me. Use a list of words instead of searching the whole dictionary during the game. I mean, that seems like a good idea. Yeah, it would be a one-time thing. Yeah, my concern is it's kind of let's get it up here again. Okay. Like if we did 3, SGT is probably not a prefix of any of these words. And there's some amount of going around. It's like, when is it worth looking? I almost think if the guess is less than 4 letters, like, why are we looking up contained? Right? We don't even care. And prefixed could be, yeah, go ahead and try it. Yeah, I mean, I guess that could be a thing we did here if the length is less than 4, we know the word is not contained in the dictionary, and it's not a valid guess because we require 4 or more letters. So if it's less than 4, we don't need to do the contained check, but that's built into this. The only way that would work Well, what if we had our three-letter? Okay, yeah. So, what if we said a two-letter contains is always going to be false true? It's not in the dictionary because it's not four letters, and it's always a prefix, even if it isn't. I mean, I don't think GK starts a lot of words, but I wouldn't have bet anything on SD, and there it was yesterday. So who knows? But you know, almost every two-letter combination. Well, I don't want to say that. We could pretend that every two-letter word is okay, and it would let some things through. But a special three-letter check would definitely kick them out. Because I don't care if it's ZZZ or ZZY, they're not in the dictionary, and every ZZ word is gonna get kicked out. So I think we could check that. The question would be, can we check three-letter extensions significantly faster than we can do what we're doing with contains and prefixes? And if we could, then maybe contains and prefixes could call that quick way first for short words and not do it for longer words. And the quickest way would be 1 or 2 letters. Sure, I got it. 3 letters, let me check real quick. 4 letters, we're going to look in the dictionary. That's kind of the breakdown. And the only reason that would work, well, the only way that would work is if looking up 3-letter words was just so much faster than calling contains and prefixes. And we get a lot of 3-letter words because every word has to be a 3-letter word before it can be a 4-letter word. So it might pay. Yeah. I don't object to it for sure. This is another reasonable idea, but again, we've proven that selecting the word, looking the word up at the end isn't bad. Should be valid even for false true, since 3-letter words are valid. Yeah, every 1, 2, or 3-letter word should get false on the first. Now, if we return false true, okay, well that I could get behind. Let's try that. Vocabulary. Some tests will break. But we're going to avoid the binary search. If target.count is less than game.minimum size, return false true. Okay. False true says, far as you're concerned, I contain that prefix. You should keep going, but I don't have that word. Okay. And let's run it, and then we'll fix tests if we think this is making any difference. It does save lookups on all those 3-letter words. Yeah, there's definitely tests that use short words. And maybe we can configure something. Now that's not a fast start. Okay. Let's close this and run it there. Yeah, I don't. It might be a hair faster. It's not. It's not hyper dramatically faster. I don't think it's doing anything. So we're still generating. Well, let's try it this way. This says just don't bother binary searching the 2-letter words, but do 3 or more. Again, I don't know that it's going to make a difference. Whoops, is it building? Okay. Oh, that seemed faster. Let's I would say it seemed faster. $1,001. I'm not sure. I think I'll kill that, and it's still something we could explore, but it may just be like this binary search is not, well, it's not nothing. I mean, if it's 18 bits, right, we're going to have to do some amount. I guess, we're going to tend to do 18 searches. So to get to any arbitrary position in the word list. Now, it may be... There is some subtlety because the distribution of letters you can get to in our board doesn't really match the distribution of letters in the alphabet because they're constrained because they're next to each other. But, yeah. All right. So let's clean up with what we have. Sounds strange. Yeah, I don't know. I mean, 3 is saying go ahead with any 3-letter word, and we're filtering them out now because we do the binary search for them. And yeah. And if we did the binary search, we get the exact answer, and that might might save enough in the valid cases and not blow out enough in the ones we let through that are invalid. So yeah, I don't know. It's well, like if we want a factor of 10, right? We either have to make this 10 times as fast, or we have to find a way to cut down the number of words we test in the first place. And I think the prefix test was the big thing that cut things down, because once it knows there's no point extending this, it stops. I do still think there's... because we're searching systematically and extending and then backing up and extending. Every point... Well, maybe that's not true. I was going to say there's once you've gone a certain length in the selection, there's only a small set of words that can continue it. I mean, once you get a 4 or 5 letter words, there's just not that many possibilities beyond it. Some situations have a dozen. Lots of situations have 1 or 2 or 0. And it feels like you could pass. I mean, if we're passing back, like if I knew what are all the valid next characters for this word, once I get to 4 or 5 letters, there's going to be a handful probably. Yeah. The way the dictionary, I mean, yeah, like this. You got to wait. Now you can do I, L, S, Y. Anything else? E. Okay. That's... Where's ways? There it is. Okay. You get way... Oh, if you get to wait, you've only got a handful of choices. If you get to weight lift, you got 2. It's a small number of choices. And it feels like if we could feed that back in the game, in the lookup, the vocabulary, if instead of a Boolean that says I have words with prefixes, we handed you back, here are the valid next letters. And it seems like you could look at your neighbors and go like, okay, well, there's no point trying the X, and that would do it. It's faster to use a dictionary with some prefix key. Yeah. I mean, and I still go back to that radix search or try. kind of thing, the Patricia thing. It may be that because like there's so much redundancy in a dictionary from one word to the next word or words in the same neighborhood, all these kind of cluster together. There's weight-ing with stuff, weight-less with stuff, weight-lift with stuff, weight-s with stuff. That trie structure puts those things kind of together, and maybe the prefixes, I don't know. It feels like we're losing some information because once we know it's got some certain prefix like weight, like there's just not that many possibilities left, and you shouldn't extend past those. It would be interesting. So that's kind of my two things left on the search side. One would be go to that whole trie solution and build up the layers with fragments of words that extend to other words and all that. And that is that's a reasonable thing. Okay, it does feel like it'd be faster to use a dictionary with some prefix key. There'd be a much smaller word lost to look up. Oh, yeah, so you're saying the 3 or 4 letter prefixes? Yeah, it is a lot less. There is something called a perfect hashing function, and that says I define this function and it guarantees that no 2 words in my list hit the same hash slot. My roommate in graduate school, that was basically his thesis. I'm not sure if that was his whole PhD thesis, but that was a part of it for sure. And this was back in the days when CDs, like how do you build a library index on a CD was a question. And, if you could go to exactly the right track on the CD for any lookup, that's pretty valuable. And that was what this minimal perfect hash function gave you. It gave you, unique hashes for exactly a list of that many hash slots. And so your index was very nice. You just transformed and boom, you know where to go, which track or whatever. That could be the right thing for the 3-letter lookup. I mean, 3 letters, 26 cubed, right, is not amazingly gigantic. You could just have a bitmap that says, where do you go for these? Yeah, we need to look for prefixes. Now, it may be, well, again, I come back to is there a way to cut down how many words come into these methods? We trim out ones that can't be the prefix. I don't see a good way to go beyond that. I mean, the only way beyond that I see is this thing of passing back letters, and you just check your letter, your neighbor letters against these possible ones. It might work. I mean, it would mean we wouldn't have to. It would cut down the number of words we search because you get B-O-B. Now, I can think of 2 words, Bobby and Bob White, off the top of my head. So B-O-B is kind of, I mean, it's a reasonable word at this point. And its neighbors, B-O-B-I, I don't know any, B-O-B-M, B-O-B-Y, B-O-B-W, yes, B-O-B-H, no, B-O-B-V, no, you got that twice. Only 1 letter actually came up as being in that list that we would get back from this hypothetical. What are the next valid neighbors? And then in our game, we would change, we'd get back that list. Would that be coming in or somehow? I mean, we want to pass that list along, and you get the neighbors, and we'd kind of like to intersect them with that list and only search the neighbors that match the list. Yeah, yeah, something like that maybe. I mean, there's it would take data research basically, but there's going to be some prefix size that is like far enough, you know. Now, we had weightlifter and all those long words, but there's just not that, like beyond, like way has a fair bit here, 204 to 240. Okay, so 32 words. Why Weimaraner has only got two, like there's some amount, like I guess it would be how many words start with any four-letter thing. We kind of know that answer. And what letters do they start with? Like, I feel like between those, you probably got room for it. So I keep saying I'm stopping working on this performance thing, and yet I'm not stopping working on the performance thing. So let's try and stop working on the performance thing. Now, the thing I do want to deal with is this game, not so much performance, just more code quality kind of thing. Let's, let's get rid of that. These two things share this bit of code here. They don't share how do you choose the selection. Now, they kind of could. I could make up a way. Yeah, it is fun. I mean, we did noticeable stuff, right? I mean, something goes from 3 hours to less than a second, and we're worrying about, can I make it a tenth of a second? It's got a charm to it. It's a challenge, and it's not like a thing with just one solution. There's a lot of ideas kicking around, so that's fun. All right, now, yeah. So I think if you get the neighbors for the selection, and then you do neighbors for each, all this stuff, okay, in a way, this is doing that, but the neighbors for an empty selection should be all these. Now, I don't know. Given a selection, what is open neighbors? Yeah, so if selection.last is nil, meaning there's nothing selected, then open neighbors could do that. So that's kind of the thing of, all right, well, I want to do this safely. I'm not sure I can. Okay, so if it's open neighbors, okay, I mean, if I started off with row index.first and column index.first, well, I don't even need that. I mean, I can just start 0, 0. I don't even need 0, 0. Okay. Let's select, can we do this? Now up here, do we say selection equals selection of grid? Yeah, that's the first. Okay, I'm going to if I say selection equals selection of location. All right, I think this line is, I think we could say new selection here. Let's try and make it more similar before we make it more different. Is selection of selection and location. Okay, so instead of this, and then this has to be new selection. Okay, so we create the initial selection. Oh, I am changing more than that, aren't I? All right, I still think it's valid because we create an initial selection based on the grid that's empty. And then we do select that added that selection in. If we do this, it basically copies the grid from the empty one and adds a selection in. Okay, let's make sure that's a true statement. But yeah, that's all it does is appends that, copies the information and appends that. Okay, so I believe that is legitimate. Okay, now I suspect there's more we can do, but let's make sure this runs or tests. Now, what we've done is we've made a starting point. We've made a new selection for each location. Okay, all is good. No, it's not good. All right, why is this one failing? Is it the only one? Okay, one failure. Game all answers equals set of A. All right, let's go back to game and see why that would be. Okay, so row indexes is 0, column index is 0, location is 0, selection is off the grid, against this one character grid, and then the new selection is empty location. So it should just be the letter with letter A in it because that's the location at row and column. Okay, and then new selection. Okay, so we do contains and prefixes. Is it, that should give us true, false. It is contained and it's not prefixed. We insert the A and we don't do anything else. So is that a true statement for a one-letter guess and a one-letter board? Okay, so this should be hitting this corner case, right? Words of index equals target. It was in the dictionary. Index plus 1 is 1 is equal to words.count. So this returns true, false. All right, let's walk this test. And I'm going to break here. Now he said he found the empty list. Oh, maybe not. Okay. So let's see what target is. Should be A. Nole. Oh, right. No, wait, what's going on? Where's that test? Okay, no. Okay, game. Find all answers in a one-cell board. Vocabulary A. What's your vocabulary? It's a lot of stuff. Why? That, oh, all answers probably assumes, no? Where does he get his vocabulary? Okay, let me answer your question. Do we change new selection after it was created? We don't. It's only used here. But I'm puzzled. We gave it a vocabulary, and yet it's not using the vocabulary we gave it. Game takes a vocabulary. Make sure we gave it the vocabulary. 1A vocabulary. Okay, so vocabulary with A. Let's check that again. We don't do anything except take what we're given. Okay. This is odd. All right, I guess it's what we're doing today, the rest of the day. Okay, so game A vocabulary. Let's stop here. Now here's game. We call trial extend. Well, we get all answers first. Sorry. All answers. And yeah, we'll run here and here. Try again. Yeah, we don't change it, but we pass it down, and down in there it changes it, extends it from there through the open neighbors. Okay. Let's look at game. Wait, why are we calling all answers? Oh, I think this is because the way we're running tests, it actually runs our app. Okay, let me take this out. We haven't hit the test yet. Okay, so let's run. Take that out. Run. Now we're in our test. Our game.all answers. I should not have called that line yet. Let's print game. Hopefully it has. Where are we? Breakpoint. Why don't we break before the expect? Finds all answers. Be twist up. Okay. Thank you. Is that all I'm getting? Test finds all answers. Expectation failed. Line 173. Okay. Let's break here. Oops. Run the test. Okay, I think I'm here, and that's the old message. All right, let's look at game. Okay, it's got all those random numbers for the colors. Maybe this is better. Vocabulary. One value. Good. Okay. Now game.allAnswers. Let's set some breaks here, here, and vocabulary. And we'll continue. Okay. Vocabulary is not a set anymore. No, because our contains and prefixes wants the list so it can do the binary search, because it does that. So I got rid of the set. We could have kept both ways, but it costs money to set up the set as well. Costs time anyway. All right, so here I'm going to continue to here. Wait, why are you here? Continue. Okay. So let's look at selection. One value A. Good. Okay. And then I'm going to step over and let's see, contained false. Well, that's not so good. So we never hit this breakpoint. It may be we have an off by one on these index things or something. Let me see. Let's put the break there, but we're going to turn it off until we get into the game. So this one turns off too, and so does this one. All right, so now we'll run this again. LLVM profile node, not written to file, already written. Okay. All right, we should break here. Yes. Okay, now I can turn these back on. I think this is the one that counts. And this. We'll continue. We should get here. Okay, and if we continue, we should get here. Okay. So let's make sure we know what words are. Good. Okay. Target, and then, well, target better be A2 as well, right? Target is empty string. That seems off. That seems like this is not... Okay, let me go up here. Let's just see what we have. Huh. Okay, something's wrong with selection. No, I don't think it's the contains. We said create this new selection. And then we ignored it. Okay. Is that what goes on down here? No. Okay. I'm going to revert because we're done for the day. But I think this would do it. So maybe I'm not going to revert. I'm going to run tests. We'll take out some breakpoints. But I'm introducing a divergence between how does the first one work and the second one. I'm still failing a test. Okay, I'm going to revert. We'll pick up there tomorrow. And what's your difference here? Expectations fail. Oh, I added the print. I can revert that too. Okay. Okay. So, sorry, Monday. You're right. Okay. So, Monday, this is refactor all answers and try, what do we call that? Trial extensions? Okay. That'll be good. I think there's similarity there. I think we can have a notion that an empty selection, it has neighbors everywhere. Okay. And if that works, then this will fold into one routine, and I think that would be an improvement. All right. Well, thanks so much this week. We're coming along. I mean, this is getting to something that you can. We'd turn this off, you wouldn't see it, but I think we're getting to something that's getting all the pieces in place and what we want. I have several changes to make, and there's things we can do, but it feels to me like we're on track for what we're doing. The performance stuff, that can be a bit of a chase, but we made a lot of progress this week, and hopefully there's more to make. All right. Well, we'll see you next week, 2 to 4:30 Eastern Time, 6 to 8:30 p.m. UTC, Monday through Thursday. I think I'm home all of October. We'll see. All right. Have a good evening and a good weekend. Bye-bye. Thanks again.